Now that we have a basic understanding of the R language, we'll dive a little deeper into a few powerful features. First, we'll start with writing our own functions. Functions make your life easier by allowing you to reuse code over and over again. In R, functions are stored as objects, just like most other things. The basic structure of a function is as follows. Let's open up an R script, just a blank one. We'll write a little pseudocode. We'll have something called myFunction, myfunc. We call the function function. We then specify a number of arguments, arg1, maybe with some defaults, myarg1, arg2, myarg2, then curly brackets, and inside the function we actually do something. And then at the end, the final line of code is evaluated, or what we usually do to make it more explicit is we call the function return, and we put the object that we want to return inside. So return object. So that's not a real function, but that is a little bit of pseudocode to give you an idea of what it should look like. So let's delete that, and as a simple example, we'll start by making a function that takes two inputs, a and b, and finds the squared difference between the two. We'll call it squared.diff. And again, we give it the name of the function, and then we call the function named function. You see it highlighted in blue. Two inputs, a and b, curly brackets. And because this is a very simple function, we only need one line of code. We'll give it return a minus b squared. And there we go. We have our function. Once we execute this code, we'll highlight it and hit run. The function is going to be available right here in our memory or in our global environment. And we can also see that it's available by typing ls below, and you would see everything that's in the global environment. If we simply type the name of the function, squared.diff, we can see the function definition. And here you see a function that takes two things, a and b, and returns a minus b squared. So now let's try it out. Squared.diff, and let's try it with a equal to 5, b equal to 6. And as expected, we get 1. So in some cases, we might want to have default values for some of our input parameters. So here, if we were to call square.diff without anything, we would get an error. To add default values, you can define them in the function definition. So we can update this function. Let's add a default value for 2 for A and a default value of 5 for B. We'll go ahead, we'll reevaluate our function. And you can see here in the global environment, our function has changed, so it now has a default value of 2 for A and 5 for B. So now if we were to call that function, without any arguments, it would assume that A equals 2 and B equals 5, thus giving us a square difference of 9. We could also, if we wanted to, give it just one value, a value of A equals 7, and in the absence of giving any value for B, it will assume that B equals 5. So that was a pretty simple function. Now let's try one that's a little bit more complex. This next function will take a vector as an input, and we'll cut the vector in half, swap the first and second halves, thus returning a vector of the same length. So let's go here, and we'll call this vec.swap. Again, the name of the function equals function, and we're going to take an argument, and we'll call it vec, curly brackets, and then now we're in the guts of our function. So first we will find the length of our input vector, and we'll call it len.vec. We'll call the function length to get that. We'll then find the midpoint of that vector, call it mid.point. And to do that, we will actually divide the length of the vector len.vec by 2. But what we need to do is round down, so we're going to use the function floor. Then we're going to take our new vector, new.vec, and the first part of that vector is going to be the last half of the vector that we fed into the function. So we're going to take vec from the midpoint plus 1 to the end of the vector, which is len.vec. And we're then going to combine that with the first half of the vector, which is the vector vec 1 through the midpoint. And finally, we're going to return new.vec, and our function is complete. We can execute the code, and we see we have in our global environment vec.swap. We can look what the function definition is here by typing vec.swap. Now we can see if we give this new function a vector 1 through 10 as our input vector, so sequence 1 to 10, we return 6 through 10 and then 1 through 5. So we swap the first and the second halves as expected. One important thing to note is that the variables I define within my function, like len.vec, are only temporarily used while the function itself is being used. You can see here in the environment tab that none of these temporary variables are stored in the memory. One other aspect that sometimes confuses people who are new to R and to programming is that if a variable is not defined within a function, R will then look outside the function for that object definition. For example, if we can append an object x onto the return vector right here, we can reevaluate vec.swap and see if we call vec.swap with 1 through 10 as before, we get an error because there's no object called x defined within the function, or actually outside the function. Now, if we go ahead and define x outside the function, say x equals 4, see that's now in memory. If we were to call vec.swap again, you see you get the initial result of vec.swap with 4 appended to it. Now you really don't ever want to do something like this, but I point this out because finally we've shown how a number and a vector can be passed as arguments to a function, but any object, including a function itself, can be passed to a function. Let's add some additional functionality to our vec.swap function that allows us to transform the vector with a function before swapping the first and the second half. We'll add one additional argument, transform.func, to our vec.swap, transform.func, and then we will add one line of code right here at the top that says vec is going to be reassigned the value of transform.func vec. So we're going to take the initial value of the initial vector vec, and then we're going to transform it by this function transform.func. And sorry about that, we have not defined transform.func or anything like that yet. So we're going to evaluate this. So we have a new definition of vec.swap. And now we need to make some sort of transformation function to feed into our new vec.swap. What we can do is we'll create just a very simple function that takes a vector and squares it. So we'll call it square.me. It's a function that takes a vec and returns a vec squared. Very simple. We will source it, we'll run it. Now we have, just to test it out, let's do square.me 4. What should we get? We should get 16. So we know that's working. And now what we can do is we can call vec.swap. And if we just gave it 1 through 10 like before, and we give it square.me, we should receive the second half, then the first half of the squared vector of the sequence 1 to 10. And as you see here, that is actually what we got. So these were just a few simple examples of self-defined functions. In this class, you'll use many of these to explore different aspects of infectious disease dynamics. Hope this was helpful.